Okay, so 5.12. Okay, so remember we can be assessed on this. Alright. This unit is pretty much the last thing we're going to be doing, I believe. I think we've done everything else. Double check, trig, linear, intro to calculus, circles, done parametrics. And we haven't need to do the quadratic function. We can do it. We'll see how we go. We've done polynomials and we've done permutation combination. So the extension quadratic function, it's just again another way to solve your inequalities. Okay, so you've already looked at it with Mr. Smith. And we're about to look at another type when we finish the graphs, another option of how to solve inequalities with the variable on the denominator of the fraction, okay, and the quadratic function will then be another alternate way to solve, okay. So you will technically cover everything ready for your exam, okay, just in terms of some extra processes we'll get there when we get there. So, general graphs. So the graphs that involve polynomials on top and bottom of the fraction and a table of values will not provide an accurate representation of the graph. We need to consider some other methods. Okay? So the four main things we need to look at. So we've already looked at intercepts. Okay, so I've already told you in linear and quadratic, absolute values as well. They're very useful ways to determine where the graph lies on your number plane. Right, we've also talked about even and odd functions in mathematics, okay? The reason why we look at that, because if we have an even function, we have symmetry about the y-axis, okay? If we have an odd function, we have a symmetry of a rotation of 180 degrees around the origin, okay? Now that's handy because if we can identify the graph as either an even or an odd, all we really need to do is consider what the graph looks like in the first quadrant, and just reverse that process into the other areas of the graph depending on what type of function it is. Okay? Now, one of the more important ones, and we started talking about this in mathematics, we started talking about asymptotes. Okay? So, in your notes, so if we have some function f of x is equal to some other function g of x over another function h of x. So g of x and h of x are functions of x, typically, or they should be, always represented as polynomials. Okay? Now if that exists, we have looked at the hyperbola yesterday as well, and we saw, started identifying values that we don't have values for our domain range, and therefore we have what's called discontinuity in your curve. Okay? Now, those points of discontinuity are called asymptotes. Okay? They are essentially imaginary line that the curve gets closer and closer to as you get closer and closer to the value for the asymptote, but will never touch or cross that point. Okay? And that's going to be a key feature for your graphs in this topic. Okay? So, vertical asymptotes. The vertical will exist where your h of x equals 0. Okay, so in other words, the denominator cannot be 0 in your fraction. Where we find those points where h of x equals 0, the x value, that's where your vertical asymptotes are going to be. Okay, so going back to your hyperbola example, okay, so the value for x can't be 0 because we cannot divide by 0. Okay, what that means is there is a vertical asymptote there. Okay, and your curve will never cross or touch that imaginary line there. Okay, so typically a dotted line. Okay, now your horizontal asymptotes, so we've got vertical imaginary line and we can also have horizontal imaginary line. Okay, I found when we take the limit as x approaches plus or minus infinity, depending on which side we're looking at, okay, of the actual function. Okay, and last lesson we looked at taking limits as x approaches infinity. We need to divide each term by the highest power of x if we're going to get infinity over infinity, and that will give us the value that the curve will approach as x gets very large in either direction. Now there's another point in your table. This is more applicable for extension 2 when we do that for the graphs there, but there are some questions in extension 1 that has what's called an oblique asymptote. Okay, an oblique asymptote is one that has a slope. No. Okay. No. They do exist. I will show you an example. We will cover it in extension 2. Okay, but I've never come across an extension 1 question where it talks about oblique asymptotes. Alright? But it's in your exercises, so we'll have a go at it and it will get you prepared, ready for extension 2. Okay, so that's the benefit for you. Okay, that will exist if the degree of the numerator is greater than or equal to the degree in the denominator. Okay, and we'll talk about that more when we get to that example in C and D. Okay, and the process of finding the equation of that asymptote will be the process of doing long division. Okay. Alright, and the last thing we need to consider, so we consider the intercepts, even odd function, consider where asymptotes are, consider the domain and range. Okay, so we've talked about a lot of that in mathematics with all our graphs so far. And the final thing you can do is test some points. So pick a table of values. Okay, just get a general layout, and after you found all those other features, we'll be able to do a reasonably accurate graph of the function. Okay. When we do calculus next year, we'll be looking at another key feature of our graphs. Okay, that will assist you in these things. So we'll be doing these sort of things again next year in graphing, but we'll also incorporate some calculus in it, and that will make things even easier again. Right, any questions so far? Right, so let's look at the first example. Okay. Y is going to be x over, 1, x plus 5. Okay, looking at that, can we identify what type of graph it's going to be? Yep. Hyperbola. Just don't say hyperbola. Don't say that ever. Alright, so what we're going to do is incorporate the skills with the more straightforward example, where you've probably got an idea what it looks like already, and then we incorporate that information. Okay? So, number 1, intercepts. Okay, so we follow these 4 steps, and then maybe needing a table of value at the end if we need some extra information on how the graph appears. Okay, but if you follow these 4 steps and do the graph as a result, okay, we should be able to do a reasonably accurate sketch of a more complicated graph. So,
where x equals.
what do you mean?
That's basically it. 1 over x plus 5. X is going to be negative 5.
The limit.
Yeah.
X is not equal. It can't be 0, so it's just...
Yeah, so we'll talk, that's what we're doing when we're talking about limits. Yep.
Yep, and then b will be 2 shifted up, or
No.
slope different?
No, because the square.
Oh,
Okay. But it's good that you're thinking about it. Okay, but remember this plus 2 is incorporated in the function because it's in the denominator of the fraction. Okay, if it was 2 over x squared and then at the end plus 2, it'll be the graph of 2 over x squared shifted up by 2. Okay, so getting this idea of thinking, yes, is because it's important in extension 2 as well. So it's good that you was thinking about it already, but we'll get in more detail when we get it. Okay, so like this one here, sorry, while we're out on the topic, this is 5 times the function. Okay, so it's going to change the slopeness of that graph if we knew what the original one, of course, looks like. Right. Okay, let's find the intercepts. So we can see that there are no x-intercepts. Okay, so let's justify it with our math, and we can see that there's going to be a y-intercept, some value close between, say, a half and 0. Let's justify that. Alright, so x-intercept. Okay, we should notice that the opposite letter equals 0. So 0 is going to be 1 on x plus 5. Okay, so considering solving for x, so if I swap these two values around, okay, so I have an x plus 5 is going to be 1 on 0. Okay, and I think we can stop there because we see that we can't divide by 0. Okay, so at this point I would put a line through. It can't be equal to 0. Okay, so therefore no solution. Okay, so we're thinking about this already, that when we graph this, there's going to be no point where it's going to touch or intercept our horizontal axis. Right, one intercept. Okay, so we've got a value for the y-intercepts, 1 over 5. Okay, if we need to write that as decimal, which looks about right because according to my graph. Okay, so it would probably be useful as well, maybe on the side or when you finish, we do a rough sketch of everything that's going to look like so far. So on the side, okay, so I've got no solution for my x, however I know I've got a 2, 0.2 for my y. Okay, so rough sketch first, get the general idea what it's going to look like, and then do a good sketch. Okay. 2. We need to now see if we have even or odd. Alright, so the original function, f of x, is 1 over x plus 5. We need to now calculate f of minus x. So 1 over minus x plus 5, which is not the same as the original. So we don't have an even function because this is not equal to that. For an even function to exist, f of x must equal f of negative x. Hey?
Okay,
I
basically.
can never remember that, like...
Yeah, you do. Yes, you do.
I had it yesterday, but then apparently that just disproved it. I thought because if f of x equals f of negative x, then the function must be negative because it's swapping a negative to a positive, so negatives make a positive.
Rightio. Okay, and for an even odd function, f of negative x must equal negative f of x. So minus 1 over x plus 5. Okay, because the numerator is positive, I'm going to put the negative in the denominator. Okay, so 1 over negative x, but that would become a negative 5. Okay. So none of those three things exist, therefore we don't have an odd or even function. Okay, so remember. Now, we do have symmetry, okay, so let's not get confused about that. We do have symmetry, okay, but for symmetry to exist, it must be symmetrical about your vertical axis, not the asymptote itself, okay. So, for this particular example, we do not have symmetry. However, if we did just your 1 over x, we will have an odd function because what you got in the first quadrant is rotated around 180 degrees, and you got the same thing in the third quadrant, in the rotated about the origin.
What are these used for?
So,
What are hyperbolas used for?
used for
I can understand.
there is an answer, and I'm just processing that. I'll get back to that answer. Okay. Alright, so therefore, f of x is neither even or odd. Okay, so I know that when I'm going to sketch it about the origin, I'm not going to have the symmetry. Okay. Okay, number 3. So we're now looking at asymptotes.
You look so snobby.
So f of x is 1 on x plus 5, which is your g of x over h of x. So both of them are polynomials. Okay, and you should always get polynomials for these style examples. Okay, so vertical. Asymptote. Not tope. I kept spelling T-O-P-E for years and I never realised I was wrong. Alright, vertical asymptotes exist where h of x is equal to 0. So the denominator of your fraction equals 0. Where you get that solution, you will have your vertical asymptote. So on the graph, hopefully see that's negative 5. You've got a vertical asymptote because the curve will never cross that. Okay, so let's justify it with our maths. So x plus 5 is 0, so x is negative 5. And there's your vertical asymptote. Right, do we have a horizontal asymptote as well? Well, we need to take that limit. Okay, so we've got the point on your curve. Okay, so we'll go right out and get larger and larger. They look like they're touching, but they're not. Okay. So we need to now justify that the horizontal asymptote is going to be the x-axis, okay, by taking the limit. Right, so horizontal
It all feels the same. It all feels the same.
Alright, so horizontal asymptotes exist where the limit as x approaches infinity technically is plus or minus, but I think we're going to see that it's going to get the same value inside, where the limit as x approaches infinity of your original function. Okay? So, equals the limit as x approaches infinity of 1 over x plus 5.
Infinity plus 5.
It's like a hole. You just chuck everything in it that goes on.
Right, so what's infinity plus 5?
Infinity.
Infinity, what's 1 over infinity? Okay, so remember that's a result of that limit. Okay, so remember
It's wrong
this.
because it doesn't matter. Everything goes wrong.
Okay, so that's the rule you need to know. Okay, so 1 divided by a very, very, very large number will approach 0. So when you have 1 divided by infinity, you have 0.
Make it 0 easy.
Okay, so that's your y value. Okay, horizontal asymptote at the y value 0. Okay, and then from that we'll be able to do our domain range. Okay, because the values of h of x equals 0 will tell you the restrictions on your domain. Okay, and the values where the horizontal, when x approaches infinity of the original function, will be your range. Okay, so 4. Domain range. Okay, so horizontal asymptote. So you've got one point where it crosses the y-axis, we've got the vertical asymptote here, we've got the horizontal asymptote there. Okay, so at this point we've already established it's a hyperbola. Okay, but we're just incorporating the skills so we can justify all the features of the parabola, of the hyperbola, sorry. Okay, and if need be, we need to do a table of values. Okay, checking some points around here. So you might check a few points here, see what's happening. Okay, we'll do that with one of the more complicated ones coming up.
Remember in physics, we had to draw sine curves.
Yeah.
We plotted I plotted every single 0.5 or something. It's so smooth. It's so satisfying.
I'll show you how to plot your sine cosine curve using a protractor and a unit circle. That'll make your graphs much easier. But the point of mathematics is when you're drawing a sine cosine curve, you're just really doing that. Yep, pretty much. Okay, so after you've done your rough sketch, okay, so then you need about a third of the page and do an accurate sketch. Okay, so both you can have a go at drawing the graph.
Just a random question, sir. How do you derive sine and tan?
How do I
Derive sine and tan because. How do you
derive?
that?
I'll show you when I graph them.
When do we cover it properly?
Intrigue function that will be in your HSC course.
In extension of
Mathematics.
I keep seeing questions with that.
Yeah, it's fine. I'm glad you're asking. I won't always have the answers for you, but I'll endeavour to get an answer for you. Right, so they're not looking for absolute perfection, they're looking for your working beforehand, okay? You're going to get marks for the information you obtain. So we've got information about the intercept, we've got information about even and odd functions, we've got information about asymptote, and we consider the domain range, okay? The majority of your marks will come from those things, okay? And really you're only going to get one mark in your graph, the graph itself. Okay, but the marks are going to come with the setup of the information that you're going through to find it, okay? Rather than giving you 4 marks purely just for how good your graph looks or something like that, okay? Alright, B. 2 over. Square plus 2. Okay, that's what it looks like.
understanding how you get that from that.
Like,
Well, this value is squared for starters, so we're always going to have a positive value in your denominator because you're squaring any value of x, whether it's positive or negative, it always return positive, and then you're adding 2 to it, okay? Okay, so that means I'm looking at that already and I'm thinking, hang on, everything is going to be above the x-axis.
I can't see where it went.
When we cover calculus in more detail in your HC course, okay, using the skills in calculus will allow us to be able to do that better than what we're doing now. But your prelim course is looking at things like limits and asymptotes to sketch your curves, okay, and that's what we're covering. Okay, anything else we noticed about the graph? That crosses the y-axis at 1, yep. Anything else?
It's symmetrical.
Good. Excellent. Symmetrical about where?
About the y-axis.
Good, so we've got what type of function?
Even.
Even function.
Michael, what am I talking about?
Any x-intercepts?
No.
Okay, because I'm not going to have a value 0. About just fine. Okay, let's do the maths and work it through. Intercepts. Have we both used GeoGebra before? Oh, no, you've used it. You show me how to plot, write a function in there.
Tried.
Yeah. Can you do something like this?
I think so.
So you're essentially doing what I've done here, a of x, a bracket x bracket equals 1 forward slash
Okay. And then
brackets,
yeah.
yep, that sort of stuff. It's like what you would do in Excel. Have you used functions in Excel? Yep. So if you have a square, you're doing the up arrow like that. Okay, and just your general syntax.
Yeah.
Right? That would be handy, obviously, when you're doing the exercises here, to be able to maybe have a look at the graphs and know what you're looking for, okay, and get an idea of what you need to find, what you're expecting for your answers, and obviously check your answers at the end. I wouldn't rely on the back of the book, because you know that sometimes they're wrong. Okay, so this is giving you an alternate way to check your answers. Right, x-intercept y is 0, so 0 is 2 over x squared plus 2. X squared plus 2 has to equal 2 over 0 if we swap the values around. Okay, so it cannot exist. So we put a slash through it, so not equals to, so therefore no solution. Okay, they're not always like that. Sometimes you are going to have an x-intercept. Okay, but for these particular examples we're not going to have one. Okay. Right, y-intercepts. So y is going to be 2 over 0 squared plus 2. It's 2 over 2, which is 1. Okay, so you can show that, that could be 1 mark. So a question like this might be worth 3, maybe 4 marks. Okay, you do this, you might get 1.
Really easy. Yeah.
Yep. Mark's not so generous in extension 2 though. Even odd function. So f of x is going to be 2 over x squared plus 2. So what's the condition for an even function to exist?
F of negative x has to equal f of x.
Good. So f of negative x has to equal the original function. So f of negative x, 2 over negative x all squared plus 2, which equals 2 over x squared plus 2. Okay, and we can't have both an even and an odd function. Okay, because the only way that can exist is a vertical line to the y-axis itself. However, that won't represent the function because it's not a vertical line test. It fails the vertical line test. Right, so therefore, f of x equals f of negative x implies f of x. Okay, so because I've obtained that very useful piece of information there, okay, all I'd really need to focus on is one side of the y-axis and then just mirror it when I work out what's going to happen on that side, mirror it on the other side, okay, and I won't have to worry about, because I think this one will do a table of values because we don't know what that looks like, okay, assuming we're not looking at this. Okay, so at some point we're going to have to do a table of values to see what's happening with the curve, okay, when we're considering the asymptotes. But just doing a table of values alone, we can overlook certain features of that graph, okay. Right, asymptotes. Okay, the vertical. Now, you can have more than one. So keeping that in mind, we can have more than one. Right. What's the condition? For a general vertical asymptote to exist, what's the condition?
H of x equals 0.
Yep, so the denominator of the fraction will 0. Okay, and that also determines your domain. Okay. So h of x, which is x squared plus 2 equals 0. Okay, solve for x. So x squared equals negative 2. Any possible solutions there? In extension 1, there's not. Okay. In extension 2, we would look at complex numbers and we look at representing complex numbers as part of your solution. Okay, so x squared cannot equal negative 2, and you won't use complex numbers in any of your other courses. Okay. So, no solution.
Remember, you know, those extension one thing, we had to with some of alpha, beta, gamma.
Yeah.
Yeah. I remember doing it and getting halfway through the question and getting square root negative like 16. I freaked out and I gave up. I just started like, what did I do?
I think one of the biggest challenges you're going to face is there will be a solution for extension 2, but you've got to put your mind in the right course. So when you see something like the square root of negative 16, well, that shouldn't happen.
Is it, so it's not touched on in extension 1 at all? So if we get a square root of negative something in extension 1 exam.
Well, there are applications. There are applications. Okay, so for example, you're finding an intercept, and you're saying somehow you worked through. You got x squared equals x equals the square root of negative 16. So that can't exist. Therefore, there will be no intercepts along the lines of what we're doing now.
So if we were doing an extension 1 paper,
Yeah.
and we found that we could use the complex numbers
Don't.
and stuff, we
Don't.
don't.
Okay.
That happens to us in math like that.
Yeah,
It's just,
all the
it's
time.
Like,
Okay, you can use your extension 1 skills in your mathematics. That's fine.
okay, sweet.
We
Okay.
get brownie points,
Okay.
extra marks.
You get your 100 markers in, yeah. Okay. But you cannot use your extension 2 stuff in extension 1 because a lot of it's a lot of it you won't even use anyway, and then things like complex numbers, they're not existent at all in extension 1.
They're not existent at all, full stop.
Alright. Horizontal.
How is it?
Alright, what's the condition for a horizontal asymptote to exist?
Limit of x approaching plus or minus infinity.
Good. Exist where the limit x approaches infinity of your original function. Okay, the vertical asymptote are the denominators where it equals 0, because we can't divide by 0, therefore we don't have any points in the curve. For those values of x, remember you can have more than one. Okay, and horizontal, you're looking at what happens if x, the value for x gets very large. Okay, the limit as x approaches infinity of 2 over x squared plus 2. Okay, so what's infinity squared? Infinity plus 2 is? So 2 over infinity is?
0.
0. Okay. Okay, so at this point, sorry, we can see our domain range. Okay, thinking about this, you found the y-intercept at 1. You have an even function. If you were to ignore the graph there, would you then be able to tell me the values for your vertical, your range? What is the range?
Yes.
Less than 1
You could.
and greater than.
Well, you can have one, can't you?
Oh yeah, greater than or equal to 1.
Because you know, yeah.
Yeah, less than or equal to 1.
Because you know that the asymptote is at 0 and it's got
Y-intercept.
Symmetry.
Exactly. Yep, so you found the y-intercept, you know that it's an even function, so you know at the intercept it's going to do the same thing on either side. Okay? However, technically, we could have something like this. Now this is where calculus is very handy. Okay, because what calculus will allow us to do is determine the coordinate of where the turning point exists on the curves. Okay, because at this point the gradient of the tangent is 0. Okay, we've learned skills to be able to find the gradient of the tangent. Okay, so when we set it at 0, we'll be able to go backwards and find the values of the coordinates. Okay, so for this style graph you would probably need to consider a table of values. Okay, so
Yeah, that's awesome.
alright, because I know I've got symmetry, okay, I don't need to go in the negative direction because I know I just need to make it symmetrical. Okay, so I'm just going to go in the positive direction. Maybe up in increments of half. Okay, maybe up to 2.5. Alright, so all you're doing is substituting that into your function. Alright, we won't do every single detail, we'll just get an approximate solution from the graph. Alright, so when x is 0, your function is 1. Okay, so you got half. If we were to put it in the calculator, we have something approximately equal to 0.8. 2 over 1 plus 2, so you've got 2/3. So approximately equal to 0.67. So you got 2 over 4 plus 2, so 4 over 2 over 6, which is approximately equal to 0.33. One and a half. Okay, 1 and a half. Looks like it's approximately a half. And then 2 and a half. Something less than 0.33 from the calculation. So let's say it's approximately 0.3 for example. Okay, so that's what you're doing in your table of values. Okay, so using it to check what your pattern is happening on the curve. Okay, and because I've got symmetry, I'll just reverse it, what's happening on the right side of the vertical axis over on the left side. Okay, so domain, so I'll consider that, and as I get larger and larger here, okay, it's just going to make that denominator bigger and bigger and make these values closer and closer and closer to 0. Okay, so domain. Are we restricted on any x values? Okay. Because there is nothing I cannot substitute in here, and it's going to return to me a value for y. Okay. Now the range. What's the condition? So.
Equal to or less than 1 and greater than 0.
So how do we write that?
With x in the middle.
1. Okay, because I know I've got the intercept here. Okay, I know there's an asymptote at 0, so it won't be equal. Okay, and after checking a few points, as I go from the intercept onwards, I'm not getting back any higher than 1. Okay, now calculus will allow us to do this much more efficiently, so your graphs are not going to be that complex compared to what could be. For your next one, going to be a bit more tricky. Okay, but in terms of turning point, okay, it's not going to be overly complex in terms of too many things happening. Alright, at this point, if you found those 4 pieces of information, you're probably getting your 2 out of 3 or your 3 out of 4 so far. I would suggest you do a rough sketch first, and then translate that rough sketch into a much more presentable sketch. Right, so the first thing we found were intercepts. So the only intercept I had was y equals 1. I know it's an even function. I know there is no vertical asymptote, but I have the horizontal asymptote on the x-axis. I know that I've got my domain, worked out my domain for my table of values, so I can have any value for x. And as I get larger and larger, looking at the function itself, as I get larger and larger, the value for y is going to get smaller and smaller. Okay, so go down and then start leveling out. Like that. And because I have symmetry, all I have to do is reverse it on the other side. Okay, so make sure you show your arrows on there because it continue, and just show that it's getting closer and closer to the asymptote, but never touches or crosses. Okay, once you've done your rough sketch and you're happy with that, okay, I mean literally a rough sketch, make it as messy as you need it to be, make sure you're happy with your answer, because there's nothing worse than doing a proper sketch and at the very end you've forgotten to consider something and you have to do that process all over again. Okay, only do your final copy when you know you're happy with your detail here. Okay, otherwise it just takes up so much time to just set it all up again. Okay, question? Alright, ramp it up a bit. Next one. Wow.
I wonder where this stops.
We'll better find out. hopefully.
Where it stops calculating the graph.
No, keep going.
Runs out of range or something.
Well, there's a turning point over 1,000 for y.
Wait, so there is a turning point.
Yeah. Because it turns around. It comes back down.
It's not in the asymptote, it goes to...
Yeah, so somewhere way up there, it turns around and then comes back down this way. Okay, calculus will be able to give us more information, but we're just looking at our, looking at...
Graph that bit?
Yeah.
Like right up.
Way up. Can I have some more paper and just line up all your papers up and just back down? Obviously, the scale's not going to be 1-to-1. Okay, but technically we could use our skills. Oh, you haven't really been taught it, but we probably could work it out. Let's make a start. Well, let's identify some features. What's some features you can tell me?
It's not symmetrical.
Very good, yes. So not expecting any symmetry.
The asymptote is... And the horizontal asymptote is 5. Y equals 5.
Okay, got a horizontal asymptote because as we go this way, okay, I assure you it doesn't go up again. Okay, just keep going that direction. Okay, any vertical asymptotes?
Yeah, that one. Or no?
No.
Actually, this might be an asymptote here.
Isn't there a thing to show?
Hey?
Isn't there a thing to show the asymptotes?
It's going to crash. Yep, there you go.
There's
2 of them. See, I told you you could have more than one.
Does that mean that there'd be like a curve in the middle of those asymptotes?
Hey?
Does that mean that there'd be something in between those asymptotes?
Okay, so there your asymptotes, dotted line. So the curve is going to go, after we find the intercept of the origin, okay, it's going to go up, way up here, never crosses this asymptote.
Oh, so there isn't a curve.
Hey?
There's not a curve at the top.
Not a turning point, it just gets...
We don't know that. We have to look it up.
No,
Oh, but when I'm showing you this and when you're learning it and doing your exercises, have a look at it first. Okay, get some information from it, see what you're expecting, okay, and then have a go. But you need to have a go at answering the questions without seeing the graph. Okay, because like I said, this can be examinable.
Right.
Alright? And I assure you that if it's going to be in your exam, it won't be overly difficult because you're just learning it. Okay, and then on the other side, it comes down, starts somewhere way up there, comes down here, and approaches this asymptote here. Yeah.
yeah.
So essentially, it's
2 lines.
doing this. From that, it turns, goes way up here, and then on the other side of the asymptote,
Would there be something in between the...
okay,
Would there be something in between the 2 asymptotes?
well, let's justify. If I find the values of my asymptotes at 1 and 2, when we're about to work it out, if I substitute 1.5, have you got your calculators? Substitute 1.5 into that function at C. X squared all over x squared take away 3x plus 2. Tell me if you get a value for 1.5.
Negative 45.
Really?
The whole thing.
Right. I got negative 45.
Oh yeah.
Negative 40. So there's more.
Yeah, there is more than what we need to show. Okay, so to do that, if you go C, could see how the function here is labelled C? Okay, if you go C of 1.5, there you go, negative 45. Alright, C of, let's go 1.9, so you're very close, asymptote at 2.
So if we scroll down,
Yeah.
will we find a curve?
Wait, why would there be something? Where is it coming from?
It's going woo.
It's
like a little parabola.
and negative 200.
It'll be a wee little parabola. There.
No.
Really cute.
There it is.
What?
I don't like this already.
That's where table value is handy to see what happened between.
But what if you miss a
Okay.
point?
Okay?
What if your intervals aren't close
Small enough,
to?
yeah. You just.
That's why you need to try some values. This is that general graph. You're not going to get it 100% correct, ever, okay, because you need the skill of calculus to be able to finish it. However, using your limit, using your asymptotes, considering symmetry, considering intercepts, and considering table values, what's happening between asymptotes, what's happening as x gets larger and larger, okay, from that information, do a sketch of the curve. Okay, now, it may be 100% correct in all cases. Alright, so what we can do is, as best we can, represent what's going on. Okay, right, let's make a start.
What are you doing those curves?
Okay,
The ones where there's like 50 million curves.
I'll show you, they won't get that hard. I assure you. Okay, so the first thing is intercepts. So where do we have the intercepts? If you edit, sorry, view. Yep, restore default setting here in option. Otherwise, right click, extend view, Control M. Okay, and that'll get you back. After you've tried to find where else your graph exists. Okay, so where are my intercepts? Just at the origin. Let's justify it. Okay, for x-intercept. y0. So 0 is going to be 5 x squared all over x squared take away 3x plus 2. Okay, so at this point we cross multiply. So 5x squared equals 0. Okay, we can do this. Okay, do you understand what I did there? I multiplied the denominator up. Right, so I've got x equals 0. Okay, so that means I know that there's going to be a y equals 0 as well. So let's justify that's the only one. Y-intercept. X equals 0. So y is going to be 0 over 0, take away 0 plus 2. Now if you have 0 divided by 0, you've got a problem. Okay, and you have no other y-intercept. Okay, so 0 divided by 2 is 0. So 0 divided by any number is 0. even and odd. Okay, so we've seen on the graph that we have no symmetry. Okay, so let's justify it with your maths, please. I'll be back in a tick.
I don't think the mic's here, so.
Yeah, I think you
Ooh.
can't start talking soon.
If you're watching this, you're a nerd.
No, you will watch it all. Not switching.
What if he becomes like internet famous and his classes become...
Why would you want to watch math lessons, honestly?
Last year
It's
when
like
we were in
carnival.
town, we're like, come on, we want to start. Okay.
They're
These
gonna
guys
sit there
like,
and go,
we're-
what the fuck? Damn these pens. This is the second pen this term.
It's gone through like 20 because Ruben keeps stealing them.
No, I actually keep going through them because my pen. Look at that.
I've gone through...
I started a tally but then I gave up.
Yeah.
I actually had a graveyard for my pens.
Oh, okay.
And once I got to like 3, I was like, nah, I'm just gonna bin them. And 3 passing points. I'm so happy. Can you see these things? Can you see this? They cost $40 a kilo at Coles. And I love them so much. And I went to Coles last night and I was like, I'm gonna buy like $5 for it. They had them marked down to $15 a kilo. I bought half a
It's still
kilo.
so expensive. What y'all about?
I bought half a kilo. Like I had no regrets. I was like, you buy it.
what?
What?
Half a kilo of what?
Oh, feta stuffed capsicums.
Wow.
No, you just eat them.
Are they good as they sound?
Yeah, they're really nice.
Yeah.
But they're $40 a kilo. It makes me really sad.
Yeah. Alright, so we justified there's no even or odd?
Mm-hmm.
You justified and you're
Yes.
telling me that there is none? Or you're telling me no, I don't know how to do it? Alright, so therefore f of x is neither odd or even. Okay, which is the pain because I've got to have to consider what's happening on both sides of the origin, isn't it? How are we going? 40. You want to stop there or you want to finish up at least the point where we're about to graph? Stop?
I don't want children trampling.
I have to go reset my mug.
Yeah.